To press record.
I could do it.
Hey, you're here.
Yes.
Fantastic. Okay.
There was no tape, so,
There was no tape?
no. So try to redirect as many people as I could.
So, welcome to the CS12 review session. Here we have a list of topics. So how this is going to go, it's going to go more Q&A than anything. So you guys give us questions, and we'll help clear up any misconceptions you guys have.
Can you go over everything?
We only have 2 hours.
Yeah.
We probably can't go over everything.
So we're on the
So we're going to start ranking the ones that you really want to go over.
So we're going to vote like which topic we're going to cover first, or if you guys want us to like cover quick questions from either our practice material or Chris's practice material. So but first let's rank these topics and in like the order you guys want. So how do you guys feel about classes themselves? So
basically just raise your hand if that's the one you want us to cover first.
So raise your hands.
Yeah.
1, 2. You have a question about classes? I guess
Quick question, otherwise can you wait for later? Because so the whole point is we'd really rather get through the questions that you feel the most, everyone at the majority feels the most uncomfortable about. So basically raise your hand if classes is the one that you really need help with. Nothing? Okay. 0. Raise your hand if recursion is what you want to hear right now. 1, 2. Pointers?
Pointers / C-sharps. That's a lot.
Okay, that's a lot.
So
Pointers.
Don't even count. Just
Yeah, that'll be our first one. Say number 1.
winner.
Inheritance?
put 2.
That looks like number 2. And then arrays?
Arrays?
Not much.
Not that much. What about pointers and arrays? Together.
Basically, okay, that'll be part 1. Dynamic memory?
Isn't that same as pointers?
That's not the same as pointers, guys.
Okay.
Oh, then yeah. Third?
Versus that, which is the same.
That's dynamic memory. And what is that?
IO.
File IO.
Is that make file?
No.
Is make file?
Make files?
Yes,
That's the big portion.
Is that really a significant portion?
That's 2 questions.
Okay.
So
How many people want?
Make file.
Make files. Make files. What's like?
so I guess.
Yeah. Yeah. No, I think not.
That's make file.
Okay. So pointers first. Pointers and these things first. Okay. So we want to go over something. Number 1 and 2. So have you guys seen the mod finals up on the outside? Yeah. The SI mod finals. You guys looking for that?
Yeah.
Okay, let's go over 1 and 2 really quick. Okay, and then we'll go over to a little bit about what, go into more detail about what's up with the actions.
So, given that this following snippet of code occurs, so I have a char star which is pointing to something in dynamic memory. It's pointing to a dynamic array of 256 chars. That's called P1. P2 points to P1. P3 points to 0, and we just declare the char star of P1. So what the question says, which of these fall in the same interval will either might cause a cycle or will cause a cycle? And as part of the answer, we'll like categorize which ones will and which ones will sometimes.
Wasn't there a delete? Yeah, wasn't there a delete P1?
Oh, deletes. That makes it possible. All right, so let's go down each of them one at a time. So, what about A? Is A something that will cause a cycle?
No.
No, it's perfectly fine. We just delete P1, whatever P1's pointing to, the stuff that, the data that P1's pointing to. And all we do is say, hey, P1, point to something else. It's going to point to a new block and not negative. It's going to point to a new dynamic array of charts. So A is okay. So what about, so B is C out dereference P3 and new line, or end line. So is that okay?
No.
No, why is that not okay?
There's no value there.
So P3 is pointing to an address 0. And 0 is a special address. We're never allowed to dereference. We're never allowed to look whatever is inside the address 0. So if we try to dereference it, it's going to, is it always going to cause a segfault or sometimes cause a segfault? It will always cause a segfault. So this is one of the answers, and this will always cause a segfault. What about C? C out P1. That's fine. So does anyone know what it's actually going to print out? It's going to print out some really, it's going to print out a,
Address.
some weird text.
Right.
Yeah.
Which is just the address to whatever previous array was there. Right.
Yeah. So that's
It
great.
hasn't changed.
So what about D?
It's not a dangling pointer after the leaf?
Well,
Which one is it dangling for, you say?
P1 is a dangling pointer. It's just that we're allowed to see out P1 itself because all P1 is an address. So if we try to dereference P1, then that's bad.
Yeah.
That will open up a possibility for a segmentation.
Remember, a pointer is just an address. An address is really just a number in memory. So if I'm trying to print out the address, that's fine. But the whole trick of dangling pointers is if it's dangling, it doesn't point to anything that's important. In fact, it points to memory that you're not allowed to access anymore. So if you try and dereference it, it might or might not give you a segfault.
Okay. So D. So who says it's going to cause a segfault? So who says it might cause a segfault? All right. And I'm assuming everyone's saying like it won't cause a segfault. So what is this operation? So what is this what's it called?
The subscript operator.
Yeah, the subscript operator. What's an alias? What's some equivalent combination of operations?
The assignment operator?
Dereference.
Just right.
So we're trying to dereference P2, basically. So the result of this is just going to be P2. Because point arithmetic plus anything, a pointer plus 0 is just the same thing. And we try to dereference P2, what happens? Since, or it might be a set fault. Since since P2 is pointing to P1, and P1 is a dangling pointer, then P2 is also a dangling pointer. So if we try to dereference a dangling pointer, then we might get a set fault. So D is a possible answer. So might get a set fault. What about E? So what address is P4 pointing to? Jump. We have no idea. So it's going to give us some jump now. So we're playing Russian roulette. Like we can be lucky and we can be allocated this value, or more likely than not, we're not. So this might cause a segmentation.
And what that is a wild pointer, which is so don't dereference null, dangling, or wild pointers, right? So wild pointers are ones where we have no idea what the address is. Okay?
So any questions?
Basic cases where you're going to get
Is
null.
that might or will cause that?
It might, because a wild pointer might point to something valid. For instance, it might actually point to
Do something else.
Some sort of garbage memory value?
basically, yeah, it's
So-
just some random generated address value.
So if I just say int x, we don't actually know what value in x
Same
is.
idea here. So if you just say pointer P4 and don't set it to anything, we don't know what's in there. It might be something that you can dereference because you have access to it. In other words, it might be like an array you've already allocated before, or it might be something completely different. Right? Yeah. Yes.
D and C do the same thing, right?
D and C, or B and C.
B and C. they're
D and
both
C
referring-
do not do the same thing.
But they're both referring to P1.
Yeah, but-
P2 is equal to P1, so they're both referring to the same address.
But we're trying to dereference. We're trying to see what's inside P2.
Yeah. So the trick there is with the subscript operator, you're implicitly dereferencing it, always. And so if you try and dereference P2 and it's a dangling pointer, then you run into issues. Here, you're not trying to dereference anything, you're just trying to output about the address.
So adding brackets is the same thing as dereferencing?
Yeah.
Adding brackets does this, it decomposes to this. Pointer plus whatever memory address you're trying to go to, dereference it.
So if I have a pointer subscript I, it's equivalent to saying P plus I dereference the result.
Yes.
So it's implicitly doing something called pointer arithmetic. So it's going to jump I spaces. So it's just going to move the pointer I spaces. So any questions about that? All right. So you guys have any questions about this from any of the sample material? Chris is speaking. So I guess we can move on.
Should we do number 2 as well?
Sure.
A little bit more pointer.
You want to try that?
Okay, I'm hoping nobody needs this because we need the camera to stay there. So let's erase this now.
Is that what it's
Yeah. Okay, so number 2 says character pointer A is equal to right. And what we want is to print out just the Batman part, right? So this is where, again, pointer arithmetic comes in. So we have a couple of answers here. Okay. So again, we're trying to print out Batman, right? So in other words, which of these statements belongs in this output to get just Batman in our screen? Yes.
Could you write a little bigger?
Yeah. Big enough? Cool. Okay. Again, so we're trying to print out Batman. Which of these statements belongs in a cout statement to get just Batman? So if I do a subscript operator 5, what's that going to do? And we just learned it literally a second ago. What happens there? B. Just B, right? So I'm going to take a plus 5, I'm going to get the pointer here. I'm going to dereference it to get a character. The character inside of the string of arrays. I mean, the array of characters, right? So I'm going to get B. That will output B. What about a plus 5? What does that do? This just gives us the pointer to B. Not the character, but the pointer to B. And if the pointer to B starts here and ends what they know, that is a C string. And if I print that out, it will print out all of that map. Yeah? So this gets us that map. Correct. What about this? Address of A of 5. So what's A of 5? A of 5 is this, right? What's the address to that? Address to that is, again, a pointer. Remember, pointers are just addresses, right? So if I take the address of where B is, that is a pointer to the start of B. And if I have, again, a pointer to the start of B, and it ends in a null character, it is a C string. That will print out that. D, what does that do? Undefined? This is not an undefined operation. So this is dereference A, right? What is that going to give us?
So what time?
Gives you I, right? Dereference of A is actually dereferencing the first character in the C string. Remember, a pointer is just the address of the very beginning of the array of things, right? So in this case, if it's an array of characters, and I have the pointer A, that just points to I, the very beginning. Dereference that, I get just the character I. So that's I plus 5, which is character arithmetic, and you guys know that is 10, right? But of course, that's not going to give us the answer. And lastly, address of dereference of A plus 5. What's that? Decompose it. So this, again, is I, right? We know that. What's the address of I? A. In other words, this is just a pointer. This is basically A again.
So
Right.
what rule of thumb is that, like, the address of and the reference operator usually cancel each other out.
Yeah.
I ask for the object, then I ask for the address of that object, but I already have the address of that object, so you do nothing.
Exactly.
And since this implicitly does that, remember that this is implicitly equal to dereference A plus 5. Dereference that, and that gets rid of that dereference operator.
So that's basically decompiling to that, which is correct. Same thing here. This is turning back to A plus 5. So this is also correct. Address of I, which is just a pointer to I again. Right? Pointing to I again is just A again. And A plus 5 will give us that. Yeah? Any questions?
You see out just A, what do you get?
If I see out just A, then I will get all of that. Right?
Why does it give you the address of?
Because this is a C string. So it ends in a null character. So the difference between just a regular array, which is just a pointer, versus a C string is that the compiler knows that this ends in a null character, so it will see out the way you want it to. If you really want to see out the address, you can give it a special flag. Like sometimes you might have seen people doing like see out hex or something. So that it'll print it out the way you want it to. But by default, if it's a C string and you see it out like that, it'll see it out.
So because it's a pointer to a C string, it knows. Okay.
Yep. Because it's a pointer to a C string and not just any other array, it knows to print it out as a string. Yes.
So if it didn't end in a null character, would
If
it
it didn't
not?
end in a null character,
And it's going to go and try to go to other places in memory where you might not have access to. So it's going to try to reach a null character. So
it's going to try to reach a null character. Yeah.
null character. I'm sorry.
So it won't print it out, or
It's going to print out a lot of nasty stuff.
Yeah. What, E is correct? Okay, so again, the reference of A gives us the character I, right? If I ask for the address of I, what I'm asking for is a pointer to I, right? So if I have a pointer to I and I plus 5, 1, 2, 3, 4, 5, I'll get a pointer to B. A pointer to B, where I'm also ending in a null character, successfully prints out B down to the null character. So I get that. The other way to think is that these basically kind of cancel out. And then these cancel out, you just get A plus 5. Yeah? Any other questions? Okay, let's move on.
So I guess the main takeaway for this question was just like equivalence of this, this, and this, and how we'll see out on treats chart stars.
How CL street chart stars and also pointer array. Remember that works. Remember that's a thing.
Alright, so this one was the first question from Chris's sample questions. And this one just says, if I have code that reads like this, I have a pointer y, which points to some dynamic variable with the value 42. It can be anything. And P1 points to y, P2 points to P1. And which one of these makes P1 a dangling pointer? So remember what the definition of a dangling pointer is. So what's a dangling pointer?
Pointer that doesn't point to anything.
It's a pointer that's pointing to like an invalid, so invalid data. Data I'm not allowed to touch, except 0. So pointing 0 is not considered data. So which one of these is the correct answer?
E.
So what do you think is the answer? So yeah, E is the correct answer because I delete P2 since P2 is now a dangling pointer and P1 is pointing. Or since P2 is pointing to the same thing as P1. So I have this P2, P1, Y, all pointing to the same memory address, which contains 42. If I say P2 deletes whatever object you're pointing to, it's going to make all of these dangling pointers. So yeah, that's the correct answer. So what about A? What does A do?
Nothing.
Yeah, it does exactly nothing. So point to whatever P1, point to whatever P2 is pointing to, but it's also pointing to the same thing. What P1 is already pointing to. So there's no change. So what about B? Yeah, it just sets P1 as 0. So it's just going to point out to the address 0. C? Same thing. Just send you to 0. It's a good thing to draw like these kind of diagrams, like which pointers are actually pointing to which blocks of memory. And what about D? D is a weird one. Is D syntactically correct?
No.
No. It's not, because Y is a char star. If I ask for an address of a char star, does anyone know what type that's going to be?
An address of a pointer.
Yeah, the address of a pointer. So just try to do type matching. So P1 is a char star. Oh, sorry, star. And Y is also an int star. When I use this operator, it's going to get the pointer version of whatever's on the right. So what's the pointer version of a, what's a pointer to an int pointer? It's going to be an int pointer pointer. Do these types match? No, it's going to be a compiled time error. So just remember when you try to ask for an address of a pointer, wacky things happen. And you just pretty much got to do this. Just make sure the types match up. So, and E is the correct answer. What about F?
Does the same thing.
Same thing. Same exact thing, but for P2. Any more questions? You want to do the last, so my number 5? Okay. So,
Want to stick with pointers by now?
yeah, I'm pretty sick of pointers.
Oh wait, possible.
The next one is inheritance. Do you find minimum value in a
Alright, inheritance. So let's do this. I want a pet, right? So dogs and cats, right? Cats are better than dogs. No.
Strong words.
Okay, so if we're gonna build a class, right, that says dogs and cats, we probably might want to do something where they inherit from some base class, right?
Yeah.
So let's start off with a class called animals. So what's special about animals that are related to the type of test we want? In other words, when we're thinking about inheritance, what we're going to think about is, we're going to have some base class and then a bunch of derived classes. The things that we want in the base class are the things that are common to all our derived classes, right? Whereas the things in the derived class are the ones that are unique to each one of those items, right? So I think that one of the things one of the things that are common to both of these is that they're going to have some kind of sound making. So let's say that they have a growl or something, right? And then the sound that they make is going to be different, right? A dog goes bark and a cat goes meow. Anything else? This is not supposed to be some giant exercise. So we'll just do private, and we'll have a string that represents the sound they make, and then the growl is just going to output it, right? Output. Virtual.
So, what sound does a generic animal make? Can someone do that for me? So yeah, you can't really. So that's kind of an abstract concept.
Take all of the sounds from every single
Yes,
animal
combine
and
it to
combine
one.
them into some kind of noise.
Duck and green.
So right, so an animal makes probably no sound in existence, right? So in other words, there probably isn't such a thing that we can just say is animal. So we're going to make it a pure virtual function, right? So the special properties of a pure virtual function is that you cannot instantiate an animal. Not instantiate. That means there will never in your code exist an object of type animal, which makes sense. A type animal doesn't exist.
So this is illegal. So sorry, no more.
Okay?
So I can actually instantiate an object of type animal, is what I'm saying.
Right. But what we do want is to be able to instantiate a type dog or a type cat, right? Because those are going to be our pets. So what we'll do is we're going to inherit from this, and this will be our abstract interface. Interface, right? So the interface means that all derived classes will be able to use these public functions that an animal has, right? So we'll do class dog. And class cat. Right. Okay. Private. And okay. So between a dog and a cat, what's going to be the difference is that the sound is going to be different, right? So how are we going to say that? We're going to set sound to something. So we should probably have our constructor here. And this will be really simple. Bark. Remember the initializer list in classes? Good.
Is there any from the
Right. So we need to have a type animal. Right.
So pretend I had.
Can you draw the constructor, the constructor for that?